This video we are going to compare and demonstrate the usage of three different plots. The first plot will be the time plot, block-based plot. I'm going to go ahead and just create them as I go here. The second will be the scope continuous plot, and then the last, the strip chart. Put that back there. Go into monitor mode, and I'm going to set the noise level down. And okay. All right, so the defaults for these plots, so the top one is the time block-based plot, the middle is a continuous scope plot, and then at the bottom is a strip chart. Now these plots all can show the same data. Now I'm gonna set them up like that first. The strip chart is, by default, will accumulate data to the length of the history, which I think is 600 seconds by default. So what I'm gonna do is go into the setup panel real quick and take the auto ranging off and set the x-axis to 0.1. So now it matches what the other plots have. So we're basically, these three plots right now are showing exactly the same data. So they're all the same channel, they're scaled at the same, and in this way they're behaving the same. Now what I want to demonstrate is how these plots differ, and there's two ways they differ. One is the amount of data they can show, and the other is how they're updated. So in order to demonstrate this, what I will do is I'm going to do each plot separately. I'm going to use this Control tab as a shortcut. I'm going to put all of them clicked up, x-axis to 0.25 on each one. And then we'll see how their behavior looks, and then I'll move it again. Okay, so the first thing you notice is as I increase the plot x-axis scaling on all of them, they're all the same at this point. You'll see the time plot is not showing all the data, and that's because this time plot is designed to only show one block of data. So even if we change the scaling, it's always showing one block of data. So if we change the sample rate or block size, this will be a different length of data here. So it's a very simple plot, and that's what it's designed to do. Now, the continuous scope plot and the strip chart are looking very similar. They both have data out to the, actually they get to 250 milliseconds. And so let's expand it out even more than that. Let's go to 5 seconds for both of them. And actually right away you can see the difference. As I changed that scaling, the strip chart immediately began adding data points, data blocks to it, all the way up to till it reached the 5 seconds. And it's actually, the new data is on the right and pushing old data off to the left. So you're seeing the most recent 5 seconds. And then this continuous scope plot is showing the last 5 seconds, but it's doing it has to accumulate, the way it's designed, to accumulate 5 seconds, then plot all the data. So during the 5 seconds, while it's accumulating data, nothing on the screen is changing. And it's hard to see with steady state data, but if I'll move the simulator off the screen, but if you were to change the amplitude, I'll move the amplitude up, you can see the strip chart's continuously updating, whereas the continuous scope is only getting one snapshot of the 5 seconds. So I can do that again, some movement and a signal. And so there you can see the difference. So the strip chart really has a lot of advantages for showing you data both in long term and updating on every new block of data. and it also can go out to a much longer time period. And the way it's designed currently is that it will plot every point until it reaches a maximum number of points of 200,000 points. So, for example, if you had 200,000 samples per second, once you exceeded 1 second on the x-axis, it would begin to summarize the data, where it used the min and the max for each block and plot that data. And this allows it to go out to an hour plus of data on the screen. And at that point, you're not really losing any information. It's only when you're zoomed in that you will need to see all the data points, to accurately represent the signal coming in. So that's it. This is a simple comparison of the time plot, block-based, the continuous scope, and the strip chart.